yesterday's recordings. They have all been uploaded. So let me share my screen. While I'm sharing my screen, everybody can see my screen. I'm going to just show you some updates so far. So if you go to Zoom and Slack links, scroll down, you go to recordings, week 1, and you'll see the welcoming, week 1 overview, part 1, part 2 have been uploaded, so you can review it, as well as the guest talk by Dr. Kevin Coble. So that has all been done and uploaded, so hopefully that'll help those that were struggling. So hopefully that will be useful. Again, so just go to the Zoom links, Zoom and Slack links on Canvas, and they are all there to access. As I mentioned yesterday as well, we have today's lessons where we go focus on ETL or extract, transform, and load have been uploaded too. So hopefully we could have had a brief overview of the content for today. So you can look at that. There were a few questions on yesterday on Slack. Just wanted to review those and kind of discuss any other admin-related questions. So if you go to frequently asked questions, the one was, will the same Zoom link be used for each week? Yes, it will be. And can we do both coding summer school projects? Yes, you can. So if you want to, you can do both. But again, there's obviously a distinction between the two. The first one is more for beginners to intermediate. And other one is open-ended project, more for intermediate to advanced, Python programmers, or those that have experience in that at least. So you can do both if you want. It's really up to you. All right. There were a few other things that I want to discuss, but yes, so in this brief part of this lesson, there were a few other queries that came up with the content we did yesterday. So again, we're just going to do a brief review from yesterday before we actually get into ETL. And the one comment that came up was just about the file structure and how the file structure works when you're creating a file and storing the data files. So okay, let's go back to our good friend Spider and see how that works again. So what we did yesterday, as you can remember, is we learned a bit about some Python skills and writing a script, which is really just a recipe of instructions that we give to Python, and it needs to output, certain things that we, expect. And then we went on to learning about pandas and how to read in various types of data files. So we had CSV files, a whole bunch of CSV files we read in, we had text files, and some of them were maybe didn't have column headers, and they were not formatted in a correct way, possibly. So we went through various different options of CSV files, as you can remember from yesterday. We also learned some useful features of pandas where we can gather information about the CSV file itself. So we learned about the .info function, that .describe function. It's more correctly described as a method, but it performs certain operations on the file. So again, info gives you information, general summary information about the file, and describe gives you descriptive statistics on numerical data for the columns that have numerical data. Then we went through, again, other files for you to just test and evaluate. And we went through other files that had maybe metadata on it, if you wanted to maybe edit those and see how they, how to edit a file that has metadata And we went through examples of that, and also the different parameters for read CSV and how that works. So yes, we had various options to work with, and this example we had here was if a data file didn't have, or CSV file didn't have column names or header names, we were able to figure that out. This example was a text file. If you want to read in a text file, we can do that also using read CSV, but this was a unique file in terms of the delimiter or the separator had a semicolon. So we just had to tell pandas, look, use a semicolon, not a comma. Yeah, so we went through various other examples, and I think most people kind of figured out how that works. So there was a few questions about the directory, or whether files kind of where they live and how you work with them. So I'm going to just kind of spend a bit of time on that to kind of look at how that works again. So yesterday, and as it explains in the notes, if you want to create a file, well, first off, because this is day 2, I'm going to create a new project. So if each day we're going to have a new project, right? So I'm going to go say project, new project, and I'm going to create a new directory. So this will create a new directory somewhere in your hard drive. So you can choose a location wherever you want. So anywhere on your drive you want it, you can locate it in your documents folder, anywhere you can put that directory. Or that project folder specifically. So I'm just going to use a default location where it is at the moment, and I'm going to call it Coding Summer School 2024, day 02. This might be difficult to see, it's quite small. I can't really change how small that is, but maybe I'll make it, put it here. So this is the project name that I'm going to use. So let me go back here. So new project, and we're going to say project name. You can choose obviously a new directory or an existing directory. I know you probably can't see this, is very small, but this is what you can just try on your own. But in any case, I'm creating a new directory for my project. And yeah, I can save it. And what you'll see is the first thing you'll see is a new Python file that says untitled.py, right? So let's now go to the actual directory in Windows. So if we open up a Windows directory, we'll go to, or we can actually do this over here, actually, just to make our lives easier. Click on this folder and show in folder. And let me just drag this across. So this is a actual location. This is the actual folder that I'm working with. Where did it disappear to? So I'm going to try and make this a bit bigger. Extra large icons. Yeah, there we go. So this is a folder. This is a folder that was created, CSS 2024 _ day 02. And then it automatically creates this .spy project. So you don't have to worry about this folder. It will, it is a config file to set up your spied environment. So we're working in this folder. We're going to put our Python files in this folder. We're going to put our CSV files, Excel files, everything, right? So, for example, I can create a new folder in here if I want, of a new file, right? You can create any kind of file you want here if you want. So I can make a text document to say, day 2, right? Day 2 file, and the extension must be .py, right? Because you're writing Python files, so the extension needs to be .py. If your Windows isn't set up to show the extension, you can edit that. But if not, then you can just ask in the chat how to actually see the extension. So I'm going to create a Python file, and as you see, I created a file here. You can see it pops up in your files directory over here. So again, hopefully you can see that, but that's how the where the files are located. So in a similar way, I can create a CSV file or even an Excel file over here, right? So I can create an Excel file, can call it whatever I want. Day 2 file, right? You can call it whatever you want. But again, as you can see, anytime I create a file in this directory, it'll pop up here. And this is ideally what we want. Our project folder is where we want to keep all our files, so it's easier to access. Okay. So this is the same way when we're creating a file here. So I can automatically, if I say new file, it will say untitled.py, untitled2.py, untitled1. Let me zoom in here. If I save this file, I can save it, day 2, file 2, maybe, whatever you want to call it. And again, it'll pop up over here. So it's saving all your files in one directory on your, in that location that you specified. So again, when we were working yesterday with the other project, if I can quickly jump to the other project, if I go to projects and a recent project and go to day 1, you can see the same thing. If I click on one of these files and just click on show in folder, and just go view extra large icons, you can see all these files are here that we're working with in the same directory. Maybe it's a bit too big, maybe just large icons. So all the data, we have our Python files we're working with, and our data files as well, or CSV files, all in the same location. And that just makes it easier for us to read in the data. So yes, so that was a question a few people had, maybe that was struggling with understanding the principle of creating files and how you use it in Spider. If you need more, clarification on that, by all means you can ask as well. Okay, Justice, thanks for your comment. Using Ubuntu, the .spy project isn't created by default. Well, you don't have to worry about the .spy project. It's just a config file, so it doesn't really make a difference. So you don't have to worry about it. So I wouldn't, again, worry that you don't have it or not. Okay. So hopefully that clarifies any questions about creating files and folders, and how we use it in Python. So, okay, let me go back here and let's go to our new project. So you should have created a new folder now, or a new project. Sorry, a new project called day 2, however you want to specify it. Okay, and we're going to be working with this file at the moment. So part of the instructions I gave for yesterday, or for today's notes at least, let's go back to the Canvas notes, see what it says. Was the extract, transform, and load. So let's have a look at that. Okay, so I just saw another question from Rahul. I asked, when creating a project, it is the same as creating a directory. As in creating a Python file and saving it in the directory. Yes, it is similar to creating a directory. The only difference is that it's associated with with Spider. So it is like creating a directory, and creating files and is saving it in a directory. So you can use that same understanding, Rahul. I hope that answers your question. Okay, so what I asked you to do is look at download the .o2.zip folder, which is over here, and put it in your project directory, right? So again, understanding what I showed you is just following on from what you're going to work with. So here is our folder, which I think I have already. So if you click on this, download it and extract it, I'll show you how to put that into your into your appropriate directory. So let me see what that is. So I have mine over here. So let me go to, if you click on one of the files, you can just say, it'll give you the option to show in folder. And then you can just copy and paste, well, not that one. This can be maybe a bit smaller. Just copy and paste this data O2 folder. So I already unzipped it, and you'll see there's a whole bunch of other files and different formats there as well. So we have some Excel files and JSON files there as well, that we're going to work with, and a whole bunch of other ones we haven't seen yet. So yes, so again, you just copy the folder and you see the current structure is we have our Python files, and we have an extra folder, and in that folder, we're going to have all our data as well. Okay, so that's ideally what you should have on your side as well. Okay, so let's go back to the notes. All right, so there's a few examples here to go over, but what we learned in yesterday's lesson is when we want to import a library. So what is the first thing that we say when you want to if you want to use pandas, what do we do? What is the first thing that we do? UCT? What's the first thing we do if we want to use pandas in our directory? Sorry? Import. And how do I import it? Can you give me the full line of code? Okay. Import pandas as PD. Do I have to call it PD? I can call it whatever. So I can call it whatever I want. Right? So would that work? Fine. Well, let's see if it works. Okay, so let's say if we have a file, if we have a file, and now instead of we had PD before, we have to say I can call it whatever we want. CSV. Invalid syntax. It doesn't like that. So I can't call it really whatever you want. Probably complaining about the underscores for the alias, for the shortcut. Let's just call it PD for now. PD.read CSV. And we want to read one of the files into our one of the CSV files, right? So do we have any CSV file currently in our folder structure in our directory? In the current directory, do we have any CSV files or any files we can read? Well, not really. We have all the files in this folder called data02. All right, so we have a whole bunch of files here that we're going to work with. And the one we're going to work with today is mostly iris, right? So we're going to work with iris. But now if we say iris.csv, which is, I'm sure everyone is quite familiar with this command at the moment. We've done it many times before yesterday. It's going to say no such file or directory. No such file or directory. Okay. So how do we access iris.csv? How do we access it? UCT, here we go. How do we access iris.csv? Where is it and how do we access it? Copy. Okay, Eunice says copy file path. Okay, we will look at that. So we say data 02, and then iris.csv. So let's see if that works. Yeah, it seems to work. We ran the file over here. Let me just zoom this in so I can see what's happening in the console. So when we saved and ran it, it ran the file and didn't give any errors or anything, so we know it works. So if we go to the variable explorer, our friend, we can see that the data set was read incorrectly. So everything works there. So there's a useful feature that I want to show everybody about. There's something called copy absolute path and copy relative path. Okay, so what happens if you copy the absolute path? What does absolute path mean, and what does relative path mean? So this is the absolute path. While I'm busy getting that, can somebody in the chat tell me a bit of difference between an absolute path and a relative path? Because we have a lot of Python experts here. So I want to know the difference between an absolute path and a relative path. So please type it in the chat, the difference between the two. Yeah, so I want to look at the chat channel, so I can't look at other comments. So just any comments you have, put it in the chat channel only. I won't look at anything else. So you can see the difference between the absolute path. So if you click on any file in your directory or anywhere else, you can access an absolute path, which gives you the full location in your folder. Sorry, on your laptop, on your computer, it gives you the full path. Okay, so it's located on the C drive, under various folders and subfolders if you want the absolute path. So the relative path gives you the location relative to where you currently are. Okay, so what I'm using here, what I'm using here is what? Is this a relative path or absolute path? Sorry? It's relative because it's assuming that we are in this current location where my Python file is, and it's looking relative to my Python file. Right, so it's looking relative to what file I'm running here, which is called day2 file 2. So let's have a look where that is again. Day2, I'm playing with this one. So relative means it's going to say, okay, I'm in this location where I created this file, because this is where I'm running the file, which is day2 file 2. And it's saying if you use a relative path, it means, okay, I'm in day2 file 2. This is a location where I am. Look relative to myself. Look relative to this location where data 02 is, or any folder that it looks for. Okay, so if I use an absolute path, then I'm giving the full location of that file. So it doesn't matter where the Python file is, it'll use the absolute path, right? Sometimes you might have data not on your own machine or somewhere else. You most likely have to give absolute path as well. So we'll look at a few examples of the two. So that was another question that was something that was commented on between different types of paths for your files and folders. So here we're using a relative path, and obviously you can see it's easier to use a relative path because we don't have to add full location. We just have to do that to read in the file. Okay, Rahul, thank you for that. Okay, so how do I get the relative path? If you click on any file inside Spider, if you right click, you get all these options, and one option is to copy absolute path or copy relative path, right? So you can look anywhere actually. You can get the absolute path from anywhere, but this is just, I know, a quick and easy way to get it. So click on any file and click on absolute path or relative path if you want it. So you can obviously go up. I mean, you can go to other locations on your machine, and you can click on any other one and get the absolute or relative path. So you don't have to obviously go to the current location. You just right click and it tells you where you are. So let me just go back here. Okay, so hopefully that clears it up. If there's anything other questions, just put in the chat and I'll follow that. Okay. So many times you might have large data or data is too large to store on your own computer, or maybe you just want to try something out, you don't want to download it. You can also get data from online if it's stored somewhere in the cloud. So the one example I have here, I'm just going to copy and paste it. Is this from this URL? So this is literally a link you can click on, and if you click on it, or let me open it up for you so I can see what it actually looks like. Oh, it's taking a while to open. Well, that's odd. Let me see if I should run it because it worked yesterday. Well, let's just call it a file again, just to be consistent. Put error. That's interesting. Why is this not working now? I mean, if anybody has data on the cloud somewhere, you can send it to me. I can try it. I'm not sure why this link isn't working anymore. It worked yesterday. Even on GitHub, if you have data on GitHub as well, you can use too. I can probably get one as well that I can quickly access. I'm not sure why this link isn't working. Let me just get another one just to show you an example of that. It did work. So why is my copy and paste not working? Oh wait, I think I might know what the problem is. Give me a moment. I think it's copying the link. I think it's copying the link as well. Oh wait. That's quite odd. I'm not sure why it's not working. Oh wait, there I can see it now. There we go. There it is. So this is what the data will look like if you just click on the link. So which is a pretty standard CSV file. However, you can see there's no headers, right? Which is a problem. We don't like that. So let's see if this works. Oh, there it goes. Okay, that's weird. And if we look at that, we'll see that, okay, there's the data as we expected, but again, there's a problem. There's no hidden names. Okay. So if you have, I can maybe give you another example of maybe if you are storing something on GitHub or any other cloud repository, how to access it. So I should have an example here. Yes, I think this one should work. This one is from GitHub, so equals pd.read CSV. Instead of that, I'm just yeah, and that gives you the same thing. So the one that is stored in GitHub, the other one is from another university site. So if you want to get data, that's another option you can do. All right, so yesterday we learned something about the column names and changing it, right? So again, I don't like having the data not have column names. So what I would do is I can I'll have the column names here. If I have the column names here, I would just say file equals pd dot read CSV. Not read clipboard. I don't know what's on the clipboard. And then you would have to specify that okay, the URL again. We can use a URL that I had before, and header. We have to tell pandas that there is no header, and we want to use our headers called column names. The variable this is what type of data structure is this? What type of data structure is this? Line 28. What type of data structure is that? That's a list, right? So we created a list with all the names of the column names we wanted, the headers, and then we're just running it. Okay. So if we run that file, we'll see that I'm going to run. We'll see that we go to file. We'll see that now each of the column names have their header name on it. Okay. All right. So that was just the first brief section that we went through. And now what I'm going to do is just to get everybody doing something. There's a quiz I'm going to publish. Should be quite a simple quiz for most people. So I'm going to publish that shortly, and then I'm going to ask you to do that. If you have any questions or comments again about what we've just covered, you can put in the chat and we'll go through it. Okay, so if you go to day 2, you should see there's a Python quiz 2. So we've got about 10 minutes to do that, starting from now. So until it closes. So please, do the quiz now. Should be quite straightforward, hopefully. But yeah, can please do that now. Everyone done with the quiz? You need a bit more time. UCT should be done, right? Anybody in the chat that's still busy, let me know. Well, you only have 10 minutes, so I can't extend that, but we can go over it a bit later. So, okay, that's fine. We'll wait another 5 minutes. So I can see about 102 students have completed the quiz so far. Average of 92%. Not bad. Okay, we have about 200 people that have finished. The percentage is dropping, not 92%, now it's 88%. But I think we'll carry on now. Let's go through the quiz questions just to make sure everybody's on the same page. I'll create another quiz a bit later on. If you struggled with this one or didn't have enough time to do it, you'll get another chance to do it later. But let's just go through it ourselves. So, okay, so Python quiz 2, variables. So stuff we did yesterday. Okay, so question 1. Which statements are invalid? Which statements are invalid? 1, 2, 3, 4, 5, 6, 7, and 8. Which ones are invalid? Option The first option, second, third, or fourth. You can put in the chat which option you did, and we'll see if I get it right or not. Third one, 6, 7, and 8. So what's wrong with 6, 7, and 8? Fourth option, I'm not sure the third is correct because third is 6, 7, and 8. Fourth, so 2. So why is 2 wrong? Why is if equals 2? Why is that a problem? We didn't actually discuss yesterday, but you should have seen it before. Well, I should have, found a problem if you try to work it out. Well, why is number this one a problem? No, it's not a word, not descriptive. You can use any word. Yeah, so there we go. We got the correct answer there. It is a reserved word. It's a built-in Python function. Well, it's more than a function, but it's a reserved word. You can't actually use it. So that's why 2 is wrong. 3, why is 3 wrong? Why is 3 wrong? Yeah, as a symbol in its special character, can't do that. So 2, why is 5 wrong? Also has a special character, dollar symbol. 6, why is 6 wrong? Same, also has a symbol, apostrophe, and 8. 8 has a space, right? So we don't have spaces when you declare a variable, so it should be the fourth option. Okay, what is the correct data type? Question 2, for a variable that stores a whole number. Answer for this one, integer. Yeah, that one should be straightforward. Question 3, what's the output of the following code? Why is it an error? Yeah, you can't add a string. You can't add a string and an integer. You need to convert one or the other if you want to do that, right? So it will give you an error, right? Question 4, what's the correct data type for storing a decimal number? Question 4, the answer for that is, yeah, a float. Question 5, what's the output of the following code? So answer for this one, question 5. 4, 2, 3. Okay. What's the data type of this one over here of X? What's the data type? Question 6, data type. It's a string. What output do you get for question 7? It's a trick question. Yeah, it's X, not 12.2, because we have a double quotes. So it's like a trick question we had there. And what output do you get for this one? Question 8. It's an error. Yeah, we haven't defined Z anywhere, so this will give an error. Output of this one, question 9. It's in a 6.0. So let's see what I got. I took more of it, actually went over time. What happens if I submit the quiz? Oh, well done. I got everything correct. Okay, that's nice. Okay, so let's go back to the notes here. So that was the quiz that was done. Okay, so before we carry on with the notes, there's obviously one of the key lessons I wanted to kind of explain is also deals with file management. Is the reason why you created a GitHub account is to store your data and your files in a code repository on the cloud. All right, so So what you're going to do is we're going to take yesterday's code and all your data and store it in your code repository that you should have created. Okay. So I have one over here. I created a GitHub repository and I called it Quantum Leap 4. Actually used a random email address just to create this. And what I've done is I created a repository for yesterday's data, right? So I'm going to show you how to do it again. And I want to do the same thing. So if you go back to Spider, we can go, let's go back to our previous day project. So this is day 1. And let's just go show in folder. So these are all the files. I want to copy all these files and put it into a GitHub repository so it's nice and safe. I can share it with other people and I can see how it, I can collaborate and see changes of the files eventually, right? But the first thing I'm going to start off with, we just copy all these files into our GitHub repository, right? And a repository is just like a folder we have on a cloud, right? That's really, you know, what we are doing with it. Okay, so how do we do that? As we've done in the notes before, I'm going to click on the plus sign. This was in the general section. Go to new repository. You can call it whatever you want, but make it obviously useful. So I'm going to say coding summer school 2024 _ day 01. Okay, that name is available. I just checking the naming convention again. I don't use spaces. I use underscores to separate words. Remember we did the snake case, you know, to declare names of folders and variable names. And I'm going to make it public so everybody can have access to it. If you want to collaborate with other people, if you want it private, you can, and only choose certain people you want to collaborate with or share it with. But I'm keeping it public and I'm going to make a README file. All right. So this is important for what you're going to do on Thursday when we're going to learn more about terminals and using Git Bash. So creating, you know, these repositories are important. So I expect everyone to do the same thing now. We're going to create a repository in our GitHub, call it, you know, yesterday's folder, for example, yesterday's work, and then going to create the repository. And then you should see something like this, like you've done before in the general section, as I explained. And in this case, we're going to upload files, right? So we're going to say there's a plus sign over here, and there's an option that says upload files. Okay. And what we're going to do is I'm going to go back to our, I'm going to select all my files here from day 1, and I'm just going to drag and drop it over here. And that's pretty much it. That'll upload all the files and folders and the data or CSV files to the cloud, which is your GitHub repository. Now, if you're familiar with Git and GitHub, you're probably wondering, what am I doing? This is not really how GitHub is used, but again, a lot of people don't know about GitHub. So we're taking things step by step. So just be patient. All right, so all the files have been uploaded and there it is. And again, to save it, we commit these files. Again, instead of saving, we're going to commit it. So commit changes. And this is all the files and folders that we're working with are now here. Okay, so it's on a cloud somewhere and we can save it, right? And a useful thing to note is that we can work with it and it's stored somewhere on a cloud, all right? So let's look at maybe just working with the README file, for example, and showing you, some useful cases of how, information on GitHub is stored and how this will relate to your own code as well, right? So again, as we followed on from the general section, if we click on edit this file, we have this environment where it's a simple text editor, really, that you can, update things. Okay, so you can say, welcome to the coding summer school. Okay, so that's just one line that, that you're going to use. And I'm going to commit that change. I can say, I can add a description to that change. We're going to say, added a single line. I'm going to commit it. And I'm going to go back to the repository and I should see that down below. There we go. I have it and it's kind of shows up. So the nice thing about a repository is a README file kind of shows up as your default presentation for the repository. So README is used to almost like metadata to describe what's happening in your repository. So if I add another line, for example, this is day one files and folders. Okay, if I commit changes, and there it is. It's showing up there. And if I go to my repo, I can show it's kind of shows the output eventually. So what is the cool thing about this is we can see the history of our changes as we go along. So say you have, you have code, you've been working on it for months and months. You can see the history of all those changes and all the updates you've made. So if I go back to my README file, which is somewhere over here, I can click on history. And I can see all these changes that I've made. So my initial commit and various updates. So if I want to go to the second one, I can see that I just added an extra line. That the pluses just show what was added to your code and everything else. Okay, so and if you want to go to that specific version, you would just click on this. You can browse the repository at this point to actually show that version of your updates at that point. So we don't only see welcome to Coding Summer School. We don't have day one anymore. So it records a complete history of all the changes you've made. And, this is a common standard, when you're developing code, for any programming language. GitHub is used. There are other ones like GitLab, but Git is the primary means to, store code and collaborate and work with it in this fashion. So just try that to create a repository, upload files. There was a question on the chat. How do you actually upload files again? So if you go back to our repository, so day 01. If you see this plus sign, you first have to create your repository and then click on the plus sign. As the option says upload files, and then you can just upload all your files there. So yes, yeah, that's pretty much it. That's a bit of a lesson just on GitHub and kind of why we're using it, just for those that have no experience in coding again, just to get an idea of how it works. Yes, Alfred, GitHub is similar to using Google Drive or OneDrive or anything else. It's a similar storage facility. It's just how things are committed or how things are saved, and the history of your files and folders are stored in a different way that is more suited for coding and programming. So it's a standard used, for programmers. How does one delete a repository? So we can click on this one. And if you go to, there's an option to do that. I think if you go to I think there's an option to do that. I can't remember, but maybe settings. Here we go. If you go to settings all the way down, you can see delete repository. And you can change the visibility, make it public or not. So yes. So you can delete repository if you want to. Okay. All right, so that's it. I just wanted to show you just basically a few features of GitHub. We'll, do some later in the week, but at least create your repository and upload your files for day one for the time being. Okay, so let's go back to our project for day two. Okay, so where were we? All right, so we were looking at absolute paths and relative paths. We were looking at URLs, getting data from there. And yes, so what is the next part of the lesson that you want to focus on? Let's have a look. All right, so we did look at brief. Sorry? Okay, so what happens if you don't do that? Have you tried it?
Yeah, I tried it.
And what happens? Really? Okay, because on my side, I usually have to specify header equals none to make sure read CSV understands that there are no header names. So you're just kind of ignoring it and specifying the column name. So you're replacing what it thinks might be the header names with the actual header names. You're just replacing it. Otherwise, it'll think the first row is a header. It will just take the first row of data as a header. Whereas if you say headers none, it'll take that name columns as the header. All right, so yesterday we looked at different file types that we can read in. So again, let's look at the documentation for pandas. So we have a variety of different data files we can read in. So again, feel free to upload your different files to the chat, and we can load it. We can load them in and have a look at them as well. So any of these file formats, you're more than welcome to upload, and we can try it out. So these are different options. I'm just going to show you a few, which is an Excel file and an Excel file and a JSON file. So where we're here, and a text file. So we did do a text file already. So if you look at the data02 folder, there's a whole bunch of CSV files, and there is a text file. There should be a text file, yeah, the geospatial data. This is a data which I looked at already yesterday, so I won't repeat that. It's a land crop and various other things. So we had the semicolon that we needed to use to separate it. So again, to get access to that file, we can say file equals pd.read CSV. In this case, should we use or what is the path that we need to do to access that file? What is the path? Well, we can click on the file, and the easier way is just to use a relative path and just paste it. But this won't work because it needs to access it as a string, right? Otherwise we'll think this is like some kind of a variable name, right? So we need to pass it a string. And then what happens if we read this, just like we saw before, it'll give an error because it's expecting, oops, sorry, that's the wrong one. It's expecting commas, but there is semicolons in this file. So we have to tell it, no, the separator is a semicolon, right? That's all we have to do. And then once we run that file, then it should work and pop up in our variable explorer. Right, and there's our data for that file, for that text file. I think somebody commented about what was in this one? It was insurance data that had all the nans in it. But anyway, okay, the next example is a Excel file. So we're not going to use read CSV. In that case, we're going to say p.read what? Excel, right? And what is the location, right? What location are we going to use? How do we figure out? Well, put in the chat. What is the Excel files over here? So what is the path that I'm going to use to access that file? I can use a relative path or absolute path, doesn't make a difference, but just put in the chat what it's supposed to be. Put in the chat what the path is supposed to be, any path. Well, either of them. I mean, not any path would work. Yeah, so there we go. So I just click on the file itself, and most people are giving me the relative path. And why would that? Why can't I use your absolute path? Why can't I use your absolute path? Why can't I use your absolute path? Yeah, again, the paths will differ, right? You have a different location where you stored your project, and you might have your project might be in the C drive or D drive or whatever drive you have. Poland, the absolute path is longer, but that doesn't make the difference is it'll be different relative to the PC that you're actually working on or the hard drive you're on. So that is what you'll get. And then if you read it in, read that in, you can read in the Excel file. Put a variable explorer, let's see what the file looks like. Yeah, so resident doctors, so data looks okay. There's a bit of this column here, age dist isn't can be maybe done a bit differently because you shouldn't mix numbers and text when you're storing values, or you should kind of try and separate them so you can do statistics a lot easier. So you should never have numbers with text. Can have categories, but you should separate it. Ideally. Yeah, so that's just reading the Excel file. You can specify the sheet. If you have different sheets, you can specify which sheet you want. Again, this will all be in the one of the parameters that you set. So I think like sheet equals the sheet name, I think so, like sheet one or something. So I'm not sure if it is called sheet one, but it should work either way. Because I only have one sheet by default, I'll just take the first sheet. And then, is there anyone that works with JSON files? Any? So give me a thumbs up to my post if you work with any JSON files. You can also import JSON files as well if you work with that. So I have an example in my directory of a JSON file over here. And then to read it in is, again, Pandas has a feature for that. So like the file equals pd dot read JSON. And then the location, I'm going to click on the file itself and just get the relative path or the absolute path. For my case, it won't make a difference. And then quotes, and then like that. And you can run it. And you have your all the fields that you can work with. So this is quite interesting. You have your subfields. What kind of data structure is this? We're looking at this at subfields. I'm not sure if you can see that. Maybe let me just print out file just so I can see it. That won't work. Oh, I can't see it there as well. I have to expand it. But in any case, this column subfields, what kind of data structure is inside each of these fields? It's a list, right? So, you might want to expand you might want to expand this column to maybe separate it into different disciplines as well. If you want to do categorical filtering or some case, because this might be you might want to separate it. So it would be useful little exercise if somebody is interested in doing that and how to do it. Okay. Okay, so other options. So this is only really if there's interest, but we're web scraping and connecting to databases if you have SQL databases, or if you want to see web scraping examples, you can do that with Pandas itself. There are other Python libraries like Beautiful Soup that does it a lot better. But if you have certain use cases or certain sites you would like to web scrape that's legal, and databases, want to like showcase how to do that. I can present that as well. Just let me know what data you want to show, or a web scraping or connecting to databases, how it works. Okay, there's about 8 minutes, 7 minutes before the tea break. I don't want to cover transforms just yet, so I think maybe we can take an early tea break and give you a bit more time for your tea. And we'll start again at 11:15. So we'll take a short break now. Thank you very much. Again, any questions or comments, please put in the chat, and then we can cover it when we come back.